Today we are going to be looking at I Can Calculate Volume in Real World Context, which is Unit 8, Learning Target 2. So in order to do this, we're going to need to use all of our formulas that we've gone through so far, in addition to a formula that you would have learned last year for a rectangular prism or cube, which is volume equals length times width times height. So when you have composite figures, you have figures that either add on top of each other, so they sit on top of each other to create a larger figure, or you have one within another, which you then have to use subtraction to help you figure out your total volume. So for example 1, we see that Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of each bead. Okay, so I should see here that I have a cube as well as a cylinder. So I have two shapes. So the first thing I'm going to do is find the volume of the cube. And if we look back at our notes up top, to find the volume of a cube, I do length times width times height, which all of those values should be the same within a cube. So that's really like doing 12 cubed, because your length, your width, and your height are all going to be the same value, and 12 cubed is equal to 1,728 millimeters cubed. Now for the cylinder, if we look here, we can see that we're given a diameter of 2, and if we remember, our cylinder formula is pi times radius squared times height. Okay, so we would be doing pi times radius. So if the diameter is 2, that means the radius is 1. And then my height is actually going to be the same as the cube because it extends all the way through the cube, because that's how beads work. So I know my height is going to be 12. Okay, so go ahead in your calculator. I want you to calculate that. Remember, we're using the pi button for pi. And then let's see what you get. Okay, so we should have gotten the cylinder was 37.6991184, so on and so forth. It goes on forever. So we're going to go ahead now. I need to figure out what is the volume of the bead. So remember that this is kind of like the open space that goes through the bead. So in order to find, I guess I can fill in my values down here. So the cube we said was 1,728 millimeters cubed. The cylinder was 37. We'll just round, so 0.7 millimeters cubed. So to find the total volume of the composite, again, the center of the bead is open, so that cylinder has nothing inside of it. So we actually need to take these two values and we need to subtract them. We need to subtract the volume of the cylinder because it's taken out of the cube. So if I take 1,728 and subtract 37.7, I get 1,690.3 millimeters cubed. So that is the volume of the bead, since the center cylinder has nothing inside of it. It's an empty space. Moving on to example 2, a roll of toilet paper has the dimensions shown, or paper towels has the dimensions shown. Find the volume of the roll. Round to the nearest tenth. Okay, so here I have two cylinders. So I have my larger cylinder, because we've all seen paper towel rolls before. So my larger cylinder, and we'll just put the large one there, and then my smaller cylinder there. So if I look at the outer cylinder, the larger cylinder, I know that I'm going to be using pi r squared times h. So I start with pi, and then the diameter of this large, or the outer cylinder, is 13. So remember, the diameter means we have to take half of that. So half of 13 is 6 0.5 squared. And then the height of the paper towel is 28 centimeters. And so go ahead, let's calculate what that volume is, and we'll round to the nearest tenth. Okay, so you should have gotten that the outer cylinder is 3,716.5 centimeters cubed. And then if we want to go ahead and find the volume of the inner cylinder, so that empty space in the center of the paper towel, we're going to be using our same formula, so pi times, now this time I have to look at that diameter it gives me of that inner cylinder, and the diameter is 4.5, which means that the radius is going to be 2.25, and the height should be the exact same since it spans the entire length of the paper towel roll. And so we're going to go ahead and plug in to our original formula. So we get 445 and 3/10 if we're rounding to the nearest tenth. And again, if I'm looking for the total composite figure, I know that that center of a paper towel roll does not have any volume within it. It's an empty space. So I am going to subtract these two values. Okay, and if I subtract those, I get a total volume of 3,271 and 2/10 centimeters cubed for the volume of a paper towel roll. Sometimes we'll have figures that actually are sitting, on top of one another to create a whole new shape. So if we look at example 3, we are going to find the volume of our solid and round to the nearest tenth. So I see here that I have a cylinder with a cone attached to it. So I'm first going to find the volume of my cylinder, and then I'm going to find the volume of my cone. Now remember, these have two separate formulas, so be careful not to use the wrong one. So for cylinder, we've been working with, so we would have pi times radius squared times height. So I can see that the diameter of my cylinder is 8, which means that my radius is going to be 4. And this is where it gets a little tricky. The height is only the height of the cylinder, so it's only going to be this 4 feet measurement. Okay, it is not the height of the entire figure. It is only the height of the cylinder, since that's what we're working with. Okay, so go ahead and plug that into your calculator and then round to your nearest tenth and see what you get. Alright, you should have gotten 201 and 6/100, which we could round to 1/10 feet. Now if I'm looking at my cone, so I'm only looking at this bottom shape here, okay, I'm going to know that with a cone, if I look back at my formulas, a cone is 1/3 pi r squared times height. So I know I'm going to be adding 1/3 in front of this times pi times radius. Now the radius is going to be the exact same as the cylinder because the base of the cylinder is also the base of the cone. So I know that 4 squared is going to be my radius. And now the height of the cone is actually going to be 5. Okay, and let's go ahead and plug that into your calculator and see what you get. If you're struggling with the 1/3, you could always do pi times 4 squared times 5 and get your answer, and then divide by 3. So if you're struggling with putting fractions in, that's another way to use the 1/3, but not trying to type fractions into your calculator. So when you do that, you get a volume of 83, and rounding to the nearest tenth, 8 feet, 0.8 feet cubed. And now, since we look at this figure, the cone is not within the cylinder, so therefore they are just adding together. So we are going to add those values together. And so if I do 201.1 plus 83.8, I should get 284 9/10 feet cubed for the total volume of this figure. Alright, example 4, find the volume inside a cylinder but outside the sphere. Okay, so this makes me think if you've ever purchased tennis balls, they're in that cylinder tube, but then you have the spherical balls inside, but there's obviously air around those. So this is that space that is around the tennis ball. So if I'm looking, the two shapes that I see is I have a cylinder, which is what is the outside package, and then we have the sphere on the inside. Oh my goodness. Sphere. Okay, so to find the cylinder, I'm going to do pi times radius squared times height. Now, the way that this sphere is inside, so if we take the center of the sphere, remember from the center of the sphere up, the top of that sphere hits the base of the cylinder. No matter which way we draw our radius or our radii inside the sphere, if we draw that radius to the outside of the sphere, it's also going to be the same as the radius for the cylinder. So I can see that the height of my entire cylinder is 6, which means that the height technically from the top of the sphere to the bottom of the sphere is 6. So if I needed to find, well, what's the radius, I would cut that in half. So it would be 3 squared. So if I go ahead and figure that out, my volume would be 169 6/10 centimeters cubed for the cylinder. And then for the sphere, remember we have a completely different formula. We're going to be using 4/3 pi times radius cubed. So I have 4/3 times pi times radius, which we just discussed was 3, cubed. Now again, if you're struggling with fractions, you can do 3 squared times pi times 4, the numerator of your fraction. Once you get that answer, then you can divide by 3, and you would get the volume of 113 1/10 centimeters cubed. Now again, the sphere is within the cylinder, so that means we are going to subtract to find the space around, the volume outside of the sphere, yet still inside the cylinder. Okay, so if I take those two numbers and I subtract, your volume comes to 56.5 centimeters cubed. All right. Right now we see a birdhouse. It's in the shape of a figure below. This should look relatively similar to an example we've already done. Suppose you want to fill the figure with birdseed. What is the volume of the figure below? Okay, so I want you to go ahead and I want you to try to figure this one out on your own, but just paying attention that we have a cylinder on the bottom and then we have a cone on the top. Okay, so go ahead, take some time, figure it out, and then when we check back in, we'll see how you did. Okay, so hopefully that you were able to get 1,282 8/10 feet for your total volume. Your cylinder, we had the height of 6, a radius of 7, so 7 squared times pi times 6, you would have gotten 923.6. And then for the cone, remember it's 1/3 times pi times your radius squared, which was 7 squared, times your height of your cone, which was 7 feet, which brought you 359.2. And then since the figures are together and not within, you're going to add those values to get that final answer. Okay, if you have any questions, make sure you email or stop by during office hours. Bye!